For the part B of this problem, we will again work with a rotated lever. That means we will take the schematic, let's just brighten it a little bit, like that. And we will rotate it till we obtain that the lever is parallel, to the x-axis or the horizontal. I think that's good enough. Now, here we are asked to determine the single force that's equivalent to the force coupled system obtained in the part A and specify its point of application on the lever. Now, that means I will replace the one system that we created here with one single force applied somewhere on the lever. So I will take the magnitude of my moment, which is actually my translator from one equivalent system to other, and paste it in here. Sorry about that. Well, it's not working anyway. It's minus 489.4 moment on B, or the moment total, it's minus 489.4 pounds inches. Now, this is going to be actually really easy. Why? Well, since we have the freedom to see the magnitude of the force and the location and the orientation, the easiest way is to select one of the 2 points that we know that can create a rotation about B. I would choose C, and we erase the other forces that we got in here and replace it with one single force that create a negative moment. I will place it in here, force. And since I wanted to go a moment like this, which is negative, I must make F to go to the lever, like that. How do I calculate that F? Well, if I choose this application point, that means that from here to B, we will get 30 inches. Hence, my moment equal to distance times force, and I already know the magnitude of my moment. I already know the distance. Just solve for the force. Force equal to my moment over distance. We will not care about the sign since we already set it in here. So 489.4 pounds inches over 30 inches. In here, the inches go away and we end up only with the pounds. So my force is going to be 489.4 pounds over 30. And that will deliver a force of 16.31 pounds. Apply it at C in a perpendicular fashion. That's the answer for B. We could get another answer if instead of choosing C as my application point, we choose A. And the bigger the distance, the smaller the force. So an equivalent force at A would be actually smaller.